This video covers the midterm review questions 1 through 5. Number 1 says, from the list of numbers, select all the irrational numbers. An irrational number is a number that cannot be written as a fraction or as a terminating decimal or a repeating decimal. So if we take a look at some of these, I can almost immediately eliminate some off the bat from the list because I know that 22 over 7 is written as a fraction, so it's definitely not irrational. 15 over 0 is not even a number. Negative 3/4 again is a fraction. Negative 5 can be written as a fraction, and negative 7.5 can be written as a fraction. So I have about 4 things or 4 numbers left that can be irrational. So if I think about the square root of 17, or even if I enter it into the calculator, I get this big, long decimal number that does not repeat itself, nor does it actually end. Now, it does look like it ends on the calculator because the calculator only holds so many decimal places. So square root of 17 is irrational. Square root of 16, you may think, well, oh, it's a square root, so it's got to be irrational. But that's not true because 16 is a perfect square, and I can write 4 as a fraction by putting 4 over 1. So the square root of 16 could be written as a fraction and is therefore not irrational. Then I have these 2 decimal numbers down here. If I look at the first one, 3.14141414, I hopefully recognize this as being repeating. It's repeating the pattern 141414. And since it's repeating, it is not irrational. The last one, 3.1411411114, you may think, well, oh, it's repeating, but it's not. It doesn't have a pattern. It changes as you move across, and so this would also be considered a non-repeating, non-terminating decimal. It's non-terminating as indicated by the ellipses. So there are 2 numbers in the list that are considered irrational. Number 2, evaluate the algebraic expression for x equals negative 2. Basically, in this problem, what you want to do, I call it plug and chug. We're going to substitute negative 2 into the equation wherever there is an x. I'm going to highlight that for you in a different color to show you what I've done. Okay, so wherever there was an x, I'm going to put a value of negative 2 because that was the given value. And then you very well could get out your calculator at this point. If we work it out by hand, I would have negative 2 cubed is literally negative 2 times negative 2 times negative 2, which would actually be negative 8. So I have negative 3 times negative 8 minus 7 times negative 2 squared. That's literally negative 2 times negative 2, which is positive 4. 6 times minus 2 or negative 2 is minus 12 plus 5. Then I'm going to go back and do the other multiplication. Negative 3 times negative 8 is positive 24. Negative 7 times 4 is negative 28 plus 12 plus 5. Working left to right, 24 minus 28 is negative 4 plus 12 plus 5. Negative 4 plus 12 is 8 plus 5 which ultimately gives us an answer of 13. So when you evaluate the algebraic expression for x equals negative 2, you get a value of 13. Number 3 asks you to simplify the radical. I notice immediately that my index is a 2, or it's understood to be 2. Remember, if there's not one written here, that it's an understood 2. So we're dealing with a square root. So I need to try to break this down. If I come off to the side and work with 75, 75 would be 5 times 15, and then 15 is 5 times 3. So if I write this all under the radical after I've broken it down, I have 3 times 5 times 5. I have 6 x's. 3, 4, 5, 6. I have 9 y's. Since it's a square root, I'm looking for sets of 2. So I have one set of 5. I have one set of x's. I have a second set of x. Third set of x. I have 1, 2, 3, 4 full sets of y's. Now there's some things left over. Remember, if it's a full set, it gets released or it gets out from underneath the radical. So I'm going to have a 5x, and there are 3 of them. Y, there are 4 of them. And then things that didn't have a partner, we have a 3 and a y. So square root 75 x to the 6, y to the 9th simplifies 5x to the 3rd, y to the 4th times the square root of 3y. Number 4 asks you to rationalize the denominator. In this particular problem, the denominator is a single term. And so it's 1 5. And so I know to make it a perfect root, it needs to have a second 5. But if I'm going to multiply the denominator by square root 5, I have to also multiply the numerator. So when I multiply the numerator and the denominator by square root of 5, I get 3 on the square root of 5 all over square root 25. But square root 25 will simplify. It's a perfect square because we forced it to be. So I have 3 square root 5 over 5. And I have successfully eliminated the radical from the denominator. Number 5 is also a rationalize the denominator problem. However, it has 2 terms. And remember, those terms that are connected by a plus or minus sign, we can think about them as being married or grouped together. And so we have to have the opposite or the conjugate of that denominator. It's the same 2 partners, so I'm going to have square root of 2 and 1, but instead of having a plus, I have a minus. I always think about it as having a female and a male. You have one of each. Okay, so then it may be helpful if you'll put parentheses around those expressions that are grouped together so that it makes more sense to you what you're going to do. We're going to distribute in the numerator. We're going to distribute the 3 times both pieces in the parentheses. So we have 3 times the square root of 2 minus 1 times 3 is 3. And then in the denominator, to multiply square root 2 plus 1 times square root 2 minus 1, we use full. Okay, so if I full this out, I have square root 2 times square root 2, which is square root 4, minus 1 square root 2 is minus square root 2, plus 1 times square root 2 is plus square root 2. Plus 1 times minus 1 is minus 1. Then I'm going to come back and combine like terms and simplify as much as I can. So I have 3 square root of 2 minus 3 over square root of 4 will simplify to 2 minus square root 2 plus square root 2 zeros out, and I have minus 1. So I end up with 3 square root 2 minus 3 all over 1. Now, we don't typically write 1 in the denominator of a fraction, so ultimately we have 3 square root of 2 minus 3, and this would be your answer. All right, that's questions 1 through 5 on the midterm review. Check out the next video for number 6 through 10, excuse me.